Combustion can generate a force equivalent to 1 billion nuclear bombs in a matter of seconds. Combustion is a fundamental process that occurs when a fuel source, typically a hydrocarbon, reacts with oxygen to produce heat and light. This process is the backbone of various industries, including transportation, energy production, and manufacturing. So, what exactly happens during combustion, and why is it so crucial in our daily lives? To understand this phenomenon, let's delve into the chemistry behind it. Imagine a grain of sand containing an entire library of intricate chemical reactions. When a fuel source, like gasoline, is ignited, it releases a massive amount of energy in the form of heat and light. But that's not the strangest part. The rate at which combustion occurs can be influenced by various factors, such as temperature and pressure. For instance, a tiny spark can ignite a massive fuel tank, but only if the conditions are right. Wait until you hear what comes next. The temperature and pressure inside a combustion chamber can reach levels that would vaporize the entire fuel tank in a fraction of a second. It's like a miniature star being born right before our eyes, with temperatures soaring to over 3,000 degrees Celsius.
But what's even more fascinating is the role of catalysts in combustion.
Catalysts are substances that speed up chemical reactions without being consumed by them.
They're like the conductors of an orchestra, ensuring that the various chemical reactions occur in harmony.
But how do catalysts work their magic? Well, imagine a maze with multiple pathways for the fuel molecules to follow. Catalysts help guide the fuel molecules through the maze, ensuring that they reach the oxygen molecules and ignite. This process is crucial in various applications, including internal combustion engines and industrial furnaces. And then something unexpected happened. Scientists discovered that certain materials can actually reduce the energy required for combustion. These materials, known as supercritical fluids, can lower the activation energy needed for combustion, making the process more efficient. It's like having a superpower that allows us to harness energy from even the most reluctant fuel sources. But what does this mean for our daily lives? Well, the implications are vast, ranging from improved fuel efficiency to reduced greenhouse gas emissions. Real-world consequences of this phenomenon are far-reaching and multifaceted. For instance, the development of more efficient combustion engines can lead to reduced fuel consumption and lower emissions. And let's not forget the impact on our environment. Cleaner air and reduced pollution are just a few benefits. But that's not all. The discovery of supercritical fluids has also led to new applications in various industries. Imagine a world where energy is harnessed from even the most unlikely sources, such as waste heat or residual energy. The possibilities are endless, and the future of energy production is looking brighter than ever. Want to learn more about the fascinating world of combustion and energy production? Subscribe to our channel for more incredible stories like this, and let's explore the wonders of science together. And don't forget to like and comment below with your thoughts on this phenomenon. We love hearing from you. If you found this fascinating, subscribe for more incredible stories like this.